In this series of videos, we're going to take a look at how to graph some rather bizarre rational functions. Each video will have a different example, however, this beginning part's going to remain the same. So you may want to skip around and watch the series if you want to see some different examples. The reason this intro is going to remain the same is because some of these rules, all of these rules, apply to every rational function we're going to do. Namely, whatever makes the top of our function equal to 0 is going to be our x-intercepts. Whatever makes the bottom of our fraction equal to 0 is going to tell us where our vertical asymptotes are. And then our horizontal asymptotes, if there is one, is going to depend on what the degree or the highest exponent of the top and bottom of our fractions are. So in other words, the first video will take a look at this example where there's a bigger degree in the bottom. Our second video will take a look at what to do when the degree is equal in the top and bottom. And our final video will take a look at what to do when the top degree is the bigger degree. So let's go ahead and look at our examples. The first thing that I like to find when I'm graphing one of these rational functions is I want to find the x-intercepts. The x-intercepts are whatever would make the top, the numerator of my fraction, equal to 0. So I'm literally going to set the top equal to 0 and then solve. In this case, I'm solving the equation 2x squared equals 0. So I'll divide both sides by 2 and get x squared equals 0. And then I'll take a square root and end up with x equals 0. Normally when we take a square root, we put plus or minus in front of our solution. There's no such thing as plus or minus 0, so I'm going to say my only x-intercept is 0. Now what I like to do, because this is a coordinate, I like to write it as a coordinate. It's 0, 0. So let me go ahead and plot that point. I don't know much about this graph, but I know there's going to be a point on the graph right there. It's going to cross the origin. All right, next up what I'm going to do is move down to the bottom of the fraction and set the denominator equal to 0. Anything that would make the bottom of the fraction 0 is going to be my vertical asymptote. There'll be breaks in the graph because I cannot have a denominator of 0. I could solve this algebraically or by graphing. I suppose I'll show you both methods. So solving this algebraically, I'll add 9 to both sides, so I get x squared equals 9. And then I'll take a square root, and as we just said, there's going to be two answers when you take the square root. Positive 3 and negative 3 would both work. So it turns out there are two vertical asymptotes this time. There'll be two breaks in the graph at 3 and at negative 3. So let's go ahead and get those drawn in as well. So 1, 2, 3. So there'll be a break in the graph right there. And there'll be a break in the graph at positive 3. So I've divided the graph up into a few different sections right now. Remember, many of these rational functions are very bizarre looking. I told you I'd show you how to factor this, so let's mention that real quick too. This is the difference of two squares, so you may recall that difference of two squares factored by taking square roots. So the square root of x squared is x. The square root of 9 is 3, and the only difference in those parentheses is one is plus and one is minus. So there's another way that might remind you that there's actually two answers to this problem, not just one. For the final part of this, I'm going to find my horizontal asymptote, and to do this, it depends on the degree, the highest exponent of the top and bottom. The degree of the numerator is 2, because that was my highest exponent, and in the denominator, my degree is also 2. Well, according to the chart we just looked at, when you have an equal degree in top and bottom, the rule is to basically do what we did yesterday and cover up and divide everything except the leading coefficients. So I'm going to ignore everything except the leading coefficients. I know this is getting really messy, but bear with me. Cover up everything but the numbers in front and divide them. So 2 divided by 1 is of course just 2. So I have a horizontal asymptote at y equals 2. So let me go ahead and draw that, and as you can see, we've now divided the graph up into 6 different sections. To actually see what this looks like, I'm going to have to graph this on my graphing calculator. So let's switch over and see what that looks like, and then we'll finish with just making a sketch of what this graph looks like. The final step of graphing one of these rational functions is actually to graph it. So we finished our analysis. Let's take a look at what this graph looks like. Notice I used parentheses around the denominator. I need parentheses anytime there's more than one term, either in the numerator or denominator. So let's hit graph, and you're going to see that this definitely is not going to be a hyperbola that we graphed previously. This is what this graph is going to look like. Now I can kind of see some things about it. I can see my vertical asymptotes appear to be at negative 3 and 3, and it appears there is a horizontal asymptote down there at y equals 0. So over here I've told you I don't need any points. I've plotted that one point, the x-intercept, because we happen to find it, but the rest of this can just be a sketch. If you need to be a little more accurate, you can certainly look at your table and you'll see a bunch of points in there if you'd like to. Notice there is that error as we predicted at 3. X can't be 3 because you'd be dividing by 0. So there is this lovely looking rational function.